Good morning, good afternoon, and good evening. Welcome back to Chapter 7, Photosynthesis. We're about to actually get into the meat of it. We're actually about to start talking about the hard stuff, which is the process of photosynthesis. The process of photosynthesis is broken up into two steps. Harvesting energy from light, using that energy to make sugar. The first step is the harvesting energy from light, and this job falls on the photosystems. The photosystems absorb light energy. Some of the electrons within chlorophyll absorbs that energy. That energy is then used to make ATP using an electron transport chain. Remember that? We talked about that at the end of the cellular respiration. We said I take a high energy electron, I pass it from molecule to molecule to molecule. The energy in that high energy electron is used to pump hydrogen ions into a very narrow space. We're going to do the very same thing again. The only difference is the narrow space is different. It's a different narrow space. Doesn't matter, still a narrow space. There are two photosystems. Now, let me explain this before we go on. And before I go on, don't get mad at me. I didn't name these. It's not my fault. The reason photosystem 1 is called photosystem 1 is because it's the photosystem for chlorophyll A. The reason why chlorophyll A is called chlorophyll A is because it was discovered first. Chlorophyll B was discovered second. So when chlorophyll A was discovered, it was called chlorophyll, and when photosystem 1, that goes along with it, was discovered, it was called the photosystem. Well, then somebody else said, oh, hey, by the way, there's another kind of chlorophyll, and it has a different photosystem. Oh, well, let's call that one B, and we'll call this photosystem 2. So that part makes sense. Chlorophyll A uses photosystem 1. Chlorophyll B uses photosystem 2. That part's easy. Guess what the hard part is? Guess which one happens first? Photosystem 2 happens first, and photosystem 1 follows. I said don't get mad. I said it's not my fault. I didn't name them. But I have to take the flack for this dumb naming system. But here it is. All right, let's talk about the two photosystems. Photosystem 2 happens first. Photosystem 2, its reaction center is called P680, and that's a really complicated way of saying a molecule of chlorophyll B. The beginning of photosystem 2 is a molecule of chlorophyll B. That's easy. Why is it called P680? Because the color that chlorophyll B absorbs best is red-orange. Red-orange is 680 nanometers long. That's why it's called P680. So my molecule of chlorophyll B is referred to as P680. Why? Because it absorbs red-orange best, or 680 nanometers best. Photosystem 2 begins with a molecule of chlorophyll B getting struck by light. Imagine, if you will, that instead of a molecule of chlorophyll being struck by light and then that molecule ejecting a high-energy electron, imagine that my molecule of chlorophyll B is a T, like for T-ball, and that the high-energy electron is the ball on top of the T. The molecule of chlorophyll B is the T, and the electron on it is the ball. Okay? Light, we just said, strikes the ball and imparts energy to it and causes it to fly away. So in my analogy of a T and a T-ball, who is the light? Well, it's the little kid that comes up and tries really hard to knock the ball off of the tee. Because if you've ever been to a T-ball game, that is not a guarantee. But the kids try really hard, and we want to, make them feel good for trying really hard. That high-energy electron is ejected. It is caught by a pickup molecule. Again, now let's kind of bridge this into, like high school baseball. The ball gets caught by an outfielder. The ball gets caught by a pickup molecule and then passed from one molecule to the next. And the energy eventually comes back out of it. And the energy in that high energy electron that got knocked off of the T, that's knocked off of chlorophyll B, that energy is used to pump hydrogen ions into a narrow space. And that narrow space is the thylakoid membrane. That ball that got knocked off of the T ultimately will fall onto a molecule of chlorophyll A. Chlorophyll A is the center of photosystem 1. We call that molecule of chlorophyll A P700, P680 because it absorbs red-orange best, 700 because 700 is red. Chlorophyll A absorbs red best. Same process happens. Electron gets knocked off of chlorophyll A, falls down stair steps, the energy is there, and then what catches this molecule, this high energy electron, is that molecule of NADPH. Remember the NADH that plants use? It's going to catch that electron. Photosystem 2 happens first. We said this. These are the light-dependent reactions. We just call them the light reactions today. Chlorophyll B is struck by light. It ejects a high-energy electron. The kid knocked the ball off of the T. The T is chlorophyll B. That high-energy electron is caught by pickup molecules and allowed to fall down a set of chemical stair steps. That high-energy electron is passed one molecule to the next. As it's passed, some of the energy is used to shove hydrogen ions into a narrow space. That electron will ultimately strike chlorophyll A. Now, pause. What do you have to do before the next kid comes up to the T? You got to put a new ball on the T. I've got to replace that electron that got knocked off of chlorophyll B. And the way I do that is by splitting apart water. Water is split apart. The oxygen bubbles away. Remember the pearls on the Elodia? I take the hydrogens from the water and I rip the electrons off of it. And I use those electrons to replace the ones that keep getting knocked off of chlorophyll B. I take the electron off of the hydrogen, turning it into a hydrogen ion. And then that electron becomes the ball, the second ball that gets put on the T. Okay? These hydrogen ions that get ripped off, they're floating around in the stroma. They're floating around, the water is floating around in the goop inside of my chloroplast. Those hydrogen ions that are going to get pumped into the narrow space are in that stroma. These are where they come from. And so those hydrogen ions in the stroma get pumped into the thylakoid membrane, into the center of it, using the energy from the electron that used to be on the hydrogen. Light strikes my molecule of chlorophyll, causing it to eject a high-energy electron. That high-energy electron, the energy is given off, and it is used to make ATP. All right, this picture is really busy. Let's talk about it in the next video.